Right, big. Quick, everybody shout out your PIN numbers and credit card numbers. Yeah. All right. All right, folks. Um, oh, nuts. Well, we'll see what happens.
Nuts. It's nuts. It's nuts.
Yeah.
Oh, it doesn't say that. Oh,
Yeah.
well, now it's.
So I think maybe that mic was muted through the whole first half.
Oh, stunning. I love that.
But you know what? We have captions, so you can just go through and read
the caption.
everything that's going on. Right? So we'll be embarrassed. We'll see what happens. I don't understand like why if that was muted, why it was picking up like my voice.
Yeah.
Right? They should have gone through.
It was picking it up on the bottom.
Yeah. Okay. Well, we'll see what happens. All right. Anyway, I want to talk about causal analysis, how we go through and actually go through and test these models. This is really pretty straightforward and easy, particularly coming off the heels of what we just done with moderation. Okay. All you're going to do is you're just going to run 3 regression models. Okay. For a simple mediation, the first model you're going to run, you're going to regress X onto Y to establish a path to be mediated. This is just your test of your path C here. Easy. Could you do this with a correlation? Yep. The only thing is, if you're running a regression model, it's going to give you coefficients to go through that you'll need for your actual analysis. Okay. What we're then going to do is we're going to regress your mediator onto your X to demonstrate a relation between your X and your mediator. Okay. You estimate this with a correlation. Yep, you could, but you need the regression to go through and get some standard errors and some effects there. So you're just establishing path A. And then what you're going to do is regress your outcome onto both your mediator and your X to establish a unique relation between your outcome and the mediator, okay, above and beyond whatever is going on with X. Okay. With this model, what you're doing is you're going to get an association with your mediator and your outcome. This is your B path. And then whatever is left over when you regress Y on a mediator and your X, this is going to give you your C prime path. Okay. What you don't want to do is, what you can't do is you can't just test X and Y, X and mediator, and then just mediator and your Y. If you just test mediator and Y, it doesn't take into account this, right? You need to have that original X predictor in there because what we'll want is this mediator account for Y independently of sort of X or what's going on. Okay. And so again, that shared association with X is going to be, or excuse me, can you send me an email to correct this slide? This should be the association with the mediator is tested with this path B, not X. So what you want to do is to determine whether your mediator completely mediates the relation of X and Y through the test of your C path here, okay, or your C prime. If you have a non-significant C prime coefficient, that suggests full mediation, okay? Or it doesn't, like conceptually, you could say, if you had C that was there, and then C goes away, C prime is equal, is not, you don't have evidence that C prime is different than 0, then we'd identify that as full mediation, okay? If you have a C prime path that's reduced, but not gone, what this might indicate is evidence of partial mediation. People seeing the logic of this? Right. So what do we do with this sort of mediation? So here's what I will say, right? if we go back to the original like Judd and Kenny papers, right, the idea would be that this C prime path is now equal to 0, right? It's got a non-significant p-value, okay? If C was strong and then you account for the mediator and C goes away, then that's kind of the best case scenario. We're like, oh yeah, we've got full mediation here. What more often happens though, is that you see that C or that X is kind of related to Y. And then when you go through and you throw in something else, another variable, then that might go away. But maybe just tips over the like the P of 0.05 line or something along those lines. In any situation where I look at the bivariate relation between X and Y, and then I throw another variable into that model, what do I expect that original path for X to do? Shrink up, right? And Lucy, if I'm right there, if I'm like P049, and then I throw in a mediator and it goes down to 055, should I be claiming full mediation of anything? No, the model's just doing what you would expect it to do, right? And so this starts to get into some of the problems with the causal steps model, okay? But let's say we get a situation where we have a reasonably strong association between X and Y. So C is very clearly there. I throw in the mediator and look at the full at my final model. We see a reduction in C, but C is still hanging on, right? Barron and Kenny would say, well, this is potentially an example of partial mediation, okay? And so what we're looking at here is the extent to which that C to C prime is started to be reduced, right? And within Barron and Kenny's model, sort of this test of mediation is a test of the reduction from C to C prime. So when we're going through and thinking about your model, okay, from an original standpoint, we're thinking about mediation as a reduction of your original C to your C prime after you have your mediator in the model, and that reduction is being the magnitude of your mediation, okay? But mathematically know that this, and this is really literally like your coefficient in your first model subtract the residual. Like this is a literal subtraction, okay? Know that this C to C prime reduction is mathematically equivalent to the product of paths A and paths B, okay? So when we're going through and thinking about things in the original causal steps approach, right? We think about mediation as this reduction of C to C prime, right? This relationship we saw, once we account for the mediator, how far does it go down? Does it go away? Think about this difference, okay? That is a way to think about mediation, but it's kind of outdated and not super flexible, okay? What I'm going to encourage you to do is think about mediation instead as evidence for this indirect path of A times B. Mathematically, they're the same. They're the same thing, right? And we'll go through and we see this. When we calculate C minus C prime, and then we calculate the product of A times B, they're the same number, okay? They're getting at the same thing. It's just as, who are my process users here? Show of hands. April, Emma, right? As you start to get into some more elaborate effects, right? We're looking at indirect effects through stuff that start to become difficult to think about as a reduction in, right? That's hard, right? It's much more flexible to think about the indirect effect of X on Y through your mediator as opposed to a reduction of C to C prime. Reduction of C to C prime works fine with this type of model, but this is very, very, very simplistic, and your models will get, and interesting models will start to get more complex, right? And so we want to be, generally, I'm going to encourage you to think about so this indirect effect as an AB path as opposed to the reduction of C to C prime. Okay. So know within this simple model, total effect of X on Y is going to be equal to the sum of all direct and indirect pathways, okay? So this is going to be the total effect on Y. C that we've estimated in our first step of the model is going to be mathematically a function of this AB path plus C prime will get you back to that original coefficient, okay? It's a closed system. Everything sums to 0. All right. So what we need to do though, with partial mediation, if we're thinking about causal effects model, right, or causal effects conceptualization, We've seen a reduction from C to C prime. What we didn't want to do is test is whether or not that's some sort of non-zero reduction in that coefficient. We know anytime we throw anything in the model, it's probably going to shrink it down a little bit. Is that reduction significant, right? And Lucy, this was your question. How do we know, like, what's the benchmark for knowing how much that has to decrease? Well, if we go through and take a classic approach, what we would use here is a Sobel standard error, okay? And how we would go through and calculate this is we would use our Sobel formula to get an approximation for the standard error of C minus C prime, okay? Your null hypothesis is C minus C prime is equal to 0, right? That there was no change, right? You're always going to see some change. And in order to test anything, what do we need? We need a standard error, right? Standard error is the standard deviation of your sampling distribution. If you were to do this over and over and over and over again, what would we expect this distribution of C minus C prime to be? And then what's the standard deviation of that? This is your standard error, okay? So your formula for your Sobel standard error is going to be your B path squared multiplied by the square of the standard error for A path plus your A path squared multiplied by the square of your standard error of B plus the product of your square root of your standard error of A and the square of your standard error of B. Okay. Take the square root of all that, and that's going to give you a standard error estimate. And what you will then do is calculate a Z score. It's going to be A by AB or C minus C prime, however you want to go through and calculate that, divided by your Sobel standard error. And that's going to give you a Z test of that partial mediation. Am I seeing where this is coming from? Questions? All right. McKinnon and Dwyer, and I like this a lot, I'm going to have you do this, suggest quantifying the magnitude of the mediation as a percentage of the total effect. Okay. So if we know that the total effect of X on Y is given as within this model as the product of AB plus C prime, what you can do is you can take A times B, the indirect effect, over total effect, and that's telling you how much of the total effect is being accounted for by the indirect effect. It's a simple proportion. This? Yeah.
Can you explain that very last part again? Why does that make it?
Well, if AB plus C is the total, captures the total association between X and Y, and I take of that total, whatever is being accounted for by the indirect effect, take the indirect effect divided by the total effect, that gives me a proportion of the total effect that's explained by the indirect effect.
Got it, thank you.
And so, April, with this, if I had full mediation, what would I expect this to turn out to?
100%.
Something that was very close to 100%. Yep. You see the logic behind this? Yeah, Lucy.
Another question, kind of on that vein, for the like AB path over, so like for the Z score, so for the AB over the standard error of AB, you said we could also just do the C path minus C prime.
Yeah.
Would we have it over the standard error of the AB path as well?
Yeah.
Okay.
C minus C prime. These are the same. They're all the same. You can sort of do it either way. I tend to like to think about it as AB just because it thinks about an indirect path, but C minus C prime is mathematically the same. It gets to the same spot.
Okay, that makes sense.
Okay.
Thank you.
Yeah. Okay. So, a conceptual example, we say, let's say, do attitudes towards support utilization account for the relationship between PTSD and social support. Okay. So we know that PTSD is related to social support. That's been demonstrated over and over and over and over and over again, right? But the question then maybe becomes like, why would we expect increased levels of PTSD to be associated with reductions in social support, right? And so what we might hypothesize here is maybe that attitudes towards support utilization, okay? It doesn't matter if I have all the support in the world if I'm wary of it and won't use it, right? I have all the money in the world and I can starve to death if I refuse to sort of buy food. Right. And so maybe what happens here is the reason, or at least part of the reason, that symptoms of post-traumatic stress disorder are associated with reductions in social support is that we know that people with PTSD are sort of wary and maybe concerned about some other people's motives and things along those lines. Maybe I'm there's a lot of guilt, shame, and things along those lines. Maybe I'm not willing to utilize support, right? So within this model, we have three variables, simple model. We have a support continuous indicator of support ranging from 0 to 7. Higher scores equal higher support. Utilization, this is my continuous indicator of attitudes towards support utilization. Higher scores indicate more negative perceptions of the utility of support resources. So the questions here are, sometimes it's good to ask people for help. Other people can be helpful. Other people will be helpful, right? Sort of things along those lines, right? Well, I guess here it's like, it's not worth to ask other people. Other people can't be trusted. Everybody's out for themselves, sort of those types of things. Okay? And then we've got a measure of PTSD where higher scores or higher levels of PTSD. So we're not going to run this in SPSS because you already know how to run regression models. That's not useful, good use of our time. So we'll just kind of work through here. Okay. Well, we're going to walk through your causal steps. Okay. So your first model, what we're going to do is just we're going to regress our outcome onto our predictor here. Okay. And here's our model, right? This is our C path, right? What we've done is our outcome variable is perceived support. Our predictor is PTSD. This is our base relation, and this is our C path, okay? And what is my C path? Do I have evidence for a relation between PTSD and perceived support in these data? Yep, I sure do, right? My coefficient is negative 0.03. Tells me that for every unit increase in PTSD, I would expect a 0.03 unit reduction in my social support measure. That seems like not much, right? Well, we know that sort of these are on very different scales, and that's what's influencing sort of the magnitude of that. If I go through and I take a look at my standardized coefficient, 0.3, pretty good, right? So I'm expecting for every standard deviation unit increase in PTSD, I'm expecting about a third of a standard deviation decrease in perceived support. I have a very small p-value, upper and lower bounds for B, and then we've got my zero order part and partial correlations. Anybody seeing Emma H? Anything curious about these part partial correlations?
Same, but it's because you're only accounting for the one.
Yeah, I just have two variables in the model, right? So that makes some sense. All right. Questions about step one? Okay. Step two, I'm going to go through and I'm going to regress my mediator onto my predictor. Okay. I'm going to establish path A. Okay. And again, I go through and do that. I regress support utilization onto PTSD. I get a coefficient of 0.25, right? Giving me evidence of a positive relation between PTSD and negative orientation towards support. Like as my trauma symptoms increase, I became more suspicious of support resources. Okay. And again, all the same stuff here. Finally, pulling it all together, the grand finale. We regress Y onto both my mediator and my original X, my X variable. So here in my model, perceived support is still my outcome, right? But now I've got a coefficient for support utilization, right? This is my B path. And Lucy, what am I seeing with my B path here?
That there is
Yep.
an association.
Yeah. So controlling for PTSD, I still have a relation between support utilization and or attitudes towards support utilization and perceived support. So I have evidence for a B path here. What happened to my effect of X here, Lucy? What is my C prime? What happened there?
It decreased.
Yeah, it decreased. What's it? Do I have evidence for an effect here in these data?
Yes, based on that, we would say that there is an effect of
What,
X and the mediator on Y.
okay.
Or-
Do I have evidence for do I have evidence for a non-zero C prime path here? Based on my output.
Oh, no.
No, right? So here, C, I have evidence for that.
Yeah.
And then here in my full model, I no longer have evidence for C prime. C prime is not significant. So based on like old school Barron and Kenny, what would I conclude based on the results of this model?
You will have a mediation effect because the relationship between X and Y is no longer present.
Exactly. We call it full mediation based on old school stuff. I'm not recommending that you do that now, but that's kind of the logic of the causal steps model. Right? And so what we see is we go from an effect of C prime, everything's reduced. This was significant, it's no longer significant. We have evidence for an A path, evidence for a B path. And so old school causal steps, we would say we have evidence for mediation here. Yeah.
I know this is like looking at the evidence for the paths, but
Yeah.
like, what is the value for like A and C prime based on these
I'm sorry, what's that? What is the value of A being?
of the paths? Yeah, like, is it the unstandardized coefficients or?
Oh, yeah. So, C is equal to negative, 0.030.
Okay.
A is 0.251.
Okay.
B negative 0.084. Yep. Good point. We'll sort of play with these in just a minute. Yeah.
I know like traditionally with t-tests and ANOVAs, we've looked at significance as something that we need to like interpret like comprehensively and
Yeah.
not as much of like a cutoff.
Yeah.
Is that not the case for mediation?
No, it still is the case for mediation.
Okay,
It's always the case for everything. Anything you do.
okay,
So yeah, always hold on to that. Yeah. So again, and this is this thing where, so this has gone down like 0.08, like that. How many people do we have in this sample? How many degrees? Where are my degrees? I don't know how many different places. There's a lot of this one, right? So we got a pretty substantial reduction. We went from something that was, a standardized coefficient of negative 0.3 down to something that's less than, like, so it's a pretty obvious reduction in things here, right? But sort of in other cases, right? And I see this all the time, and I've tried to put together my own analysis when this happens, where like I got a C, it's just kind of barely there. And then anything else you throw in the model, it's going to drop it down just on the other side. Does that mean I can throw whatever the hell I want to in the model and just claim that I have a mediated path? No, people will do it, but you shouldn't, because it doesn't make any goddamn sense, right? So this is where you have to start thinking very carefully, and this is why, and thinking about sort of the rules behind causal steps, is thinking about like sort of your mediator being a plausible agent of Y, right? And that the mediator is happening before X or that Y is occurring and things along those lines. So there's some stuff to think about. Yeah.
The I guess application or practical interpretation of like our confidence interval associated with C prime, like is it just reintroducing the information that we're getting from our significance value?
Yeah, it's the same thing. Yeah. So we're just saying, I would look here and say, sort of after I account for attitude sort of support utilization, sort of my estimates of the residual effect of PTSD on outcomes are ranging anywhere from a low of 0.02 to 0.00. Like it just barely ekes across
like
the
it's right
line,
over.
right?
Yeah.
And so even here, right, like, so we want to be very, very careful in terms of the types of interpretations that we're drawing from this stuff. Okay. So we would go through sort of old school causal effects. We'd say we have full mediation, so we don't need to do anything else with this. It's going to be hard to float in today's age, right? So what we want to do is we want to say, okay, we want to test whether or not we have evidence for this indirect effect, right? And we can think about this as a test of AB, or we can think about this as a test of C minus C prime. Doesn't matter, it's the same thing, okay? So again, here's the formula for my Sobel standard error, okay? Here's where I go through, so I have my coefficient for B is negative 0.084, standard error for A, 0.30. This my coefficient for A, 251, standard error for B, 0.009, standard error for A, standard error for B. We go through, run that out, and I get a standard error of 0.003. People see where I'm pulling these values from based on the previous table. It's basically a plug and play thing. It's pretty straightforward with things. Then what I would do is I would calculate my indirect effect. And I'm gonna calculate this as A times B, right? So that's 0.25 minus 0.084, right? So AB equals 0.251 times negative 0.084. Someone tell me what AB is.
The indirect.
Yeah, but
Sorry, oh, sorry.
Yeah. What the calculator? Got Danielle?
Wait a second, is that negative 0.804 or 0.08?
Yeah, negative 0.084.
Negative 0.021.
Go back through and take a look. Okay. Minus C prime. What is C here? Negative 0.030 minus C prime 0.009. All this stuff, order of operations will bite you. So to make sure that you're getting it correct. Okay. It gives me what is the result of this?
It's the same, I mean, just looking at it.
So you look at the big ooh, doing math in her head. No, exactly right. It's the same thing, right? So these two things are interchangeable. They're the same, right? And so it doesn't matter if you think about this as AB or C minus C prime. AB is just a little more flexible in terms of how you're thinking about stuff, and will sort of serve you better as you start to get into some more complex analyses where you've got multiple mediators and things along those lines. But mathematically, they're the same. Okay, and if I take A times B and I add negative 0.009, what do I get back to? Yeah, we get back to here, right? And so again, just making, this is another nice, anytime I've got to check on my math is a nice thing to make sure that my numbers are correct with things. So I go through and I do that, and then I usually go AB divided by my standard error. Here we go, and we get a Z of 7.03. Is that a significant Z score? Yeah, that's wild. That's huge, right? So we got a very, very small p-value, S base factor, right? So we would say yes, even though we were not surprised by this, given that we had sort of met the standards for full mediation. When we go through and run the test, we have very strong evidence for an indirect effect of PTSD on reductions in social support by way of attitudes towards support utilization. Okay. And this is how I would talk about this, and this is how I do talk about this. I'm talking about an indirect effect of X on Y by way of, yeah, okay. And then you just plug in your relevant constructs with this. Questions on what we did, how we went through and got this process? Who likes this better than moderation? Yeah, it's easier, right? Okay, questions on sort of the idea, the process, the concept. All right, so this has been to the way we did things for a long time. But what are the consequences of this? What are the limitations, right? One thing that starts to come up, and so this is maybe a misnomer in that we call this causal processes, right? Causal processes refers to sort of the underlying conceptualization and thinking about your mediators as a causal factor. There's nothing in causal processes that establishes any type of causality ever, okay? But someone said cause, and then everybody got up in arms about things and brought up some good points, right? Causal steps not sufficient to provide strong conclusions about causal processes, right? And has anybody worked in a lab where you get real worked up about sort of this idea of causality? Yeah, it tends to be our experimental folks who, like, you get people like
No
get
cause, no
really
cause, yeah.
intense, right, about this, right? You say experimental designs provide a more rigorous test, right? If I go through and I can randomize things to control for external factors, sort of different manipulations and things along these lines, right? Where I go through and I sort of manipulate this mediator on or off or things along those lines. This can be sort of a better way to go about it, but even within experimental designs, the anti-causality people get worked up about stuff, right? So they're basically saying you can never establish cause, right? But the other thing that happens too is strong arguments for mediation, really hard to establish in correlation designs, okay? If I've got cross-sectional data and I've measured X, Y, or X, Y, and M all at the same time, I should 100% stay away from sort of any of this type of language. I wouldn't even say mediator. I don't say mediator in anything. I talk about indirect effects and sort of influences, sort of variables that may help to account for a relation, right? I don't ever say mediation because as soon as you say mediation, someone's gonna lose their mind about something, okay? And it's stupid because I'm saying the same thing. Like I'm talking about this thing producing this other thing. I'm just not saying the word cause and then you get away with it. But that's anytime we're doing these types of models, this is what we're implying, whether we're saying it or not. But you just got to be careful about the type of language you're using. Now, if I go through and I have some sort of longitudinal assessment, this helps strengthen things, right? If I measure X today, mediator tomorrow, and the outcome on Friday, I'm in a better place because then I know that I can set some temporal precedents. I know that Y didn't become why didn't exist before my mediator did, right? So it still helps, but still not enough to go through and establish causality, right? What I would say is a correlational data can be helpful for determining the plausality of certain pathways. I can say, hey, this looks like it works okay in these type of data, but very much would not sort of talk about causality, right? And so people will get upset about this and say, well, causal models doesn't establish causality. I imagine sort of Baron and Kenny would probably be upset by that because like it's a goddamn word, like you're getting hung up on that. That's not what we're trying to do. But so it starts to become relevant in interpreting these models because what's being implied is that sort of this thing produces this thing, even if we don't say it. But that's what's being implied, right? So some stuff like this, okay? Questions about the causality piece of things? I will tell you this starts to become really difficult, right? Let's say, Laura, you go through and you say, here's my mediation model, here's my X, here's my Y, and here's my mediator. If I could go through and take those three variables, like shake them up like dice and throw them out on the table, producing a completely different model that makes equal conceptual sense, you don't have a strong argument for your model, right? What you need to do either through theory or some conceptualization, be able to make a strong argument that yes, this thing comes before that other thing and then leads to that thing, even if I can't test it, even if it's correlational data, right? If I say that PTSD moderates the relationship, or depression moderates the relation between PTSD and distress. Well, I don't know why isn't distress moderates the relation between PTSD and depression, or depression moderates the relation between PTSD and distress. Like if I can go through and turn this around in any different ways and they all make reasonable sense, you don't have a strong basis for these types of models. You need to have a very strong conceptual theoretical rationale for why this specific order. If I can come up with a different order that makes reasonable sense, probably in a bad spot. Okay. Longitudinal stuff can help this, but it doesn't fix it all the way. Yeah.
Is it ever, you like might have mentioned this, so sorry if you did, and I just didn't catch it. But I know like for moderation, sometimes people will do them cross-sectionally, I think. But like for mediations, because of the way that you're kind of setting it up where like X would have to come before Y, is it ever appropriate to do them cross-sectionally when measurement is like actually happening at the same time, not just like oh, we measure X at 1 hour and Y an hour later, but like literally like.
Depends on who you talk to. I would say yes, so long as you're sort of being judicious in your interpretations and you've gone through and very clearly laid out your reasons for testing the model that you did. Hayes would say the same thing, right? He's motivated because he's got a whole process thing that is really easy to use in cross-sectional data, right? But some people will say, and you'll run into reviewers that say, like, well, this is cross-sectional, you can't test mediation, right? I mean, if I've given you a good reason sort of why it should, like, why would, and again, pulling from my area, if I say, here are trauma cognitions that are then sort of leading to PTSD down the road. I measured these things all at the same time. But our theoretical models of PTSD say it's these cognitions that are driving symptoms, not the symptoms that are driving cognitions. And therefore, I put it this way. If I were to do it the other way around, it would make conceptual sense. So that's why I'm not testing that model. That's why this is sort of happening the way it is, right? Then you've got, can I sort of disentangle that cross-sectional data? No. But theoretically, it only makes sense for this to sort of go this way, right? And so that's the thing you have to think very carefully about if you're going to propose these types of models with cross-sectional data. Longitudinal stuff is always better. Doesn't fix everything, but it's you take less shit for longitudinal data than you will cross-sectional data. But you can, and I have sort of published this. It's just you have to be prepared for people who go through and take exception for that. You need to have a bulletproof reason for why we modeled it this way. Yeah. Other limitation with causal steps is this idea of a priori effects. Okay. And this goes back to, Lucy, your question about the requirement of having a relation between X and Y is problematic both conceptually and mathematically. Okay. Now, on the very, very basic surface, if I'm going to say, hey, I'm guessing that this thing mediates or acts as the mechanism for the relation between X and Y, should I have a relation between X and Y? Probably. Right? But there are reasons why this might not happen empirically. Okay. If X and Y are related or measured very close in time, you should probably have some sort of association there, right? If I measure them concurrently, I should probably have some association there, right? But as we work through, and if we start to take a developmental sort of approach, as some causal process starts to play out over longer periods of time, what we can see is the relation between X and Y starts to maybe shrink up due to transmission of that relation through other types of things, right? If I'm measuring something today and something 20 years from now, there's lots of things that can start to come into play and sort of impact, right? And so what I might see is that relation between X and Y, X today and Y 20 years from now starts to become pretty weak because there's lots of other stuff going through. We got competing processes, right? Maybe we get one mediator so that's strengthening the relation and another mediator that's reducing the relation. And those two things, if I'm not measuring everything, starts to go through and cancel each other out. So a function of random error, right? There's just all sorts of different things that are going on between how I might measure something today and something 20 years from now, right? There's all sorts of things that can start to go through and attenuate this this association, okay? So good reasons, conceptual reasons why we might not see a strong effect of X and Y to go through and mediate if these things are going on. Okay? Other cases, I can have a situation where the power of my data to detect my mediated path might be a lot better than my power to test that original direct effect. Okay? So let's say I've got a case where paths A and B are associated with medium effects. Okay, so path A, path B, both consistent with effects of 0.3, right? So a sample of 80 gives me enough power to reasonably test path A and path B. Okay, but if I have 100% sort of mediation, so my mediator 100% sort of accounts for that causal relation, right? I know that the bivariate relation of X and Y, that original C path, is gonna be 0.09. How do I know that? If I told you what A is gonna be and what B is gonna be, and I tell you that my mediator is 100% of full mediation of my model, how do I know what C path is gonna be here? X and this is Y, here's my M, right? So I say this is 0.3. And this is 0.3. If this completely mediates the relation between X and Y, what is my C path going to be? Well, I know that so my indirect path is going to be A times B. And if I know my total effect is AB plus C prime, right? I know that this is completely mediating, so what is C prime? 0, right? So my C path has to be equal to AB. I know AB is 0.3 times 0.3. That means that this original path here is 0.09. Okay. So what can happen here, Lucy, is maybe I do have a relation between X and Y, which is very weak, right? And I might have the power to detect this path, and I might have the power to detect this path, but I don't have the power to detect this path, right? Here I would need close to 1,000 people to identify this reliably, okay? So what can happen is I can go through and within a set, if I go through and test this set, and even if this is a very small but real effect, I'm going to get no evidence of an effect here, even though I get evidence of effect here and here, right? So again, mathematically, there are things that can come up and statistically can come up why I might not detect this C path, even if we do have an indirect effect available. Okay. Now, this is a very specific case where I have full mediation and sort of things along those lines, right? If you're going to make an argument of this for why you're not getting that initial C path, you need to be able to lay that out. But it is something that can happen in real life, and some reasons why we might be careful about being real hardcore about needing to see that initial C path. Kind of understand this? Okay. Other thing, Trout and Bolger paper. Okay. Talk about suppressor effects. These suppressor effects are different than the ones in Tabachnik-Abdel. That's a completely different thing. But what can happen sometimes is if I have the indirect effect of A on the indirect effect of AB is about the same magnitude, but in opposite valence of C prime, what can happen is these things can start to cancel each other out. Okay. So let's say I've got a situation where I'm saying that coping behavior, which is my mediator, is activated by environmental distress, expected to hold a positive relation with psychosocial distress. Okay. So here I'm saying environmental stress is associated as a positive association with increases in psychological distress, right? When my stress level goes up, my psychological distress goes up, okay? What I'm saying is the reason that this happens is because I've got a mediator here that is my coping behavior, okay? So if I would expect environmental stress and coping to have a positive relation, right? As my environmental stress goes up, what happens in my coping response? It goes up, okay? But I have a negative association between coping and psychological distress. As my coping increases, my stress should decrease, right? So I've got a positive A path. I've got a negative B path. So as a consequence of that, my indirect effect, my coefficient for my indirect effect is going to be negative, okay? You'll see this. But because my total effect is going to be A times B plus C prime, what I could get is a near zero effect in my initial estimation if my residual path of my C prime is positive and about the same magnitude as A times B. Okay. So again, if A times B plus C is my total effect, and A times B is -5, and C prime is the residual is +5. What's what's my total effect gonna be estimated at? 0, right? So what could happen is when I go through and I test X on Y, I don't get any effect. When I run my mediation model, I see a sort of negative effect, negative indirect effect, and my residual effect is positive, about the same magnitude. But these two things can go through and cancel each other out, so I don't actually detect an effect. These things may be related. It's just the data that just the bivariate effect is being masked by this. Okay, it's kind of the same thing that we talked about for moderation. If this is sort of my simple slopes for one group, and this is my simple slopes for the other group, what's the overall effect? The difference between these, right? So I might not find in just an effect for the bivariate stuff here. So again, mathematically, there's situations where I might not see that initial effect. Kind of understand kind of what's going on with some of this. So again, concerns with causal models, right? We've got problems with causality. They don't cause causality. We've got sort of issues with causality and things. Now, Strout and Bolger, they sort of go through and sort of lay out some guidelines, right? That like sort of this has to come before this has to be a plausible agent, things along those lines. But there's nothing about causal models that sort of should or needs to be interpreted as causal processes. We also have this sort of a priori effect, this C path, right? There are methodological reasons and conceptual reasons we might not see the C path. There are also just mathematical reasons we might not see the C path just based on stuff. So we're thinking about this idea of a priori. Should I go through, you're wanting to run a mediation model and you don't have that C path, you don't have evidence for that, like what should you do, okay? If you have some sort of thing that you've measured all at the same time, you probably should have a relation there, okay? If I measured X and Y pretty close to one another, or certainly all at the same time, I should probably have something there. It's because it's going to give me a better case for an argument for your mediation model. These are already kind of difficult to defend. It's going to be harder if you don't have that, right? So you want to have some sort of empirical or conceptual reason to say, hey, X and Y are related to one another. Okay. Now, Laura, if you go through and you say there's an entire literature that say X and Y are related, and then you run your analyses and X and Y are sort of just right, like 0.06. Is your data right and everybody else is wrong and X and Y really hold zero relation? No, right? So again, wanting to think about like sort of what does the literature say, knowing your literature, be able to draw that in as a defense, right? But really, if you're going to run these models, it's much, much easier to defend if you have some a priori association. But we might start to relax this in cases where I'm looking at distal mediational processes. So I got longitudinal designs where I'm measuring things certainly like far distant in time. I might start to think about reducing or relaxing so it doesn't need to have this initial effect. Okay. We got subtle effects of X on Y, right? So like this path and this path are going to be kind of subtle, small, and I don't have sort of a ton of people in my sample. What I might still have, I might have an effect here. I just don't have enough people to detect that, particularly in cases of full mediation. Or in situations where I might expect some sort of stressor effect, where I'm expecting my indirect effect to be about the same size but opposite valence of my direct effect or of my residual effect, then that's a situation where I might say it's a mathematical fluke that I'm not detecting this. In fact, there really is something here. Questions about this? Is this making some sense? Other thing, we've got limitations with causal effects. These are limitations of our standard errors. Okay. Our Sobel test, our classical approach, our classic approach for testing this mediated effect, the standard error we're getting is not technically appropriate. Okay. What we know about the sampling distribution of our indirect effect AB is that it's going to be skewed. It's non-normal. Okay. If I have a positive indirect effect, it's gonna be a positive skew. If it's a negative indirect, it's gonna be negative skewed, right? And so what happens is we know that the sampling distribution of AB or C minus C prime is not normal, okay? The problem is our Sobel test and its variance, it assumes a normal distribution, right? So what happens is we're looking to derive a standard error for a statistic that doesn't have a normal sampling distribution, but the standard error that we're applying, the approximate standard error that we're using, assumes a normal distribution. And so what happens is these two things don't line up with one another, okay? As a consequence, tests based on our Sobel are going to be underpowered. We're going to have too much type 2 error. And this is going to be the case under all circumstances, unless we've got really, really large samples. If you got really large samples, you don't have to worry about sort of the problems with Sobel, okay? Or if you're working with really, really large effect sizes, you probably don't have to worry about that, right? But oftentimes we're working with neither of these ones. And so what happens is we're concerned that our Sobel test, which assumes a normal theory, our Sobel provides a standard error for a normal sampling distribution. But we know for a fact that AB doesn't have a normal sampling distribution. And so we've taken, so it's like a square peg in a round hole type of thing. This. And so Sobel is an approximation, but it's not exact. And this creates some problems in terms of how stuff. Make some sense? Okay. We've got some variants on Sobel, but they're all normal theory standard errors. And when we apply a normal theory standard error to an effect or to a coefficient that we know doesn't have a normal sampling distribution, I'm pounding in nails with a wrench. It'll get the job done, but not very well, and I'll have some problems sometimes. All right. And so again, even when we calculate confidence intervals from an estimated standard error, continue to perform poorly. So there's just problems with this precision of Sobel. So what we do instead is we can go through and we can use bootstrapping procedures. Bootstrapping, we've talked about this a little bit. Remember, is a procedure where we're going to go through and generate an empirical distribution of some sort of parameter. Okay? And this is going to be your best practice way for going through and detecting and testing mediation effects. So with our bootstrapping procedure, what we're going to do is we're going to use your sample data. Okay, your sample data is your population, right? Your sample data are all the observations that there are in the universe. Okay, and so what we're going to do is we're going to go through and we're going to draw a bootstrap sample of n cases drawn randomly with replacement. So let's say, Danielle, you've got a sample of 120 people in your data set. What we're going to do is we're going to draw a bootstrap sample of 120 observations. And you might say, how does that make sense? If I got 120 people, how am I going to draw? Why would I draw a sample with everybody in there? Do I know everybody's going to be in there with my bootstrap sample of 120 people? No, why not?
It's like random with replacement. So
It's random with replacement, right? So Danielle, if you're in that sample, you may not be in this bootstrap sample, and Helena might be in there 5 different times, right? So again, what we're going to go through, and so we're going to have, I've got a sample of 100. I'm going to draw a bootstrap sample of 100. And what the system is going to do is it's going to go through and it's going to grab an observation and pull it out and then throw it back in and then do it again and do it again and do it again until I've got 100 observations, right? That are going to be one bootstrap sample. And then what I'm going to do with that bootstrap sample is I'm going to go through and I'm going to estimate all my models. Or so I'm going to go through and estimate sort of my indirect path for that bootstrap sample, right? So I'm going to have an estimate for AB from that bootstrap sample. And then I'm going to do steps 1 and 2 for say 500 or 5,000 different times, right? So what I'm going to do is I'm going to have 5,000 independent samples that I've drawn with replacement from my original sample of 100. So I'm going to have 5,000 bootstrap samples with 100 people in it. But what I'm going to do for each one of these is I'm going to go through and I'm going to map out AB for each one of these. And when I do that, what it's gonna do is I'm gonna then have stored in my, in the guts of my software system, 5,000 estimates for AB that I'm then gonna go through and plot out, okay? And then what I'm gonna do is I'm gonna use that, observe that empirical distribution of AB across J replications to start to pull standard errors, confidence bounds, and things along these lines, okay? The standard deviation of that sampling distribution that I've just created is gonna serve as an estimate of my population standard error. And what's gonna happen is if I go through, so for my sample of 100, one, two, three, four, 5,000, right? For each one of these, I'm gonna say AB equals this, AB equals this, AB equals this, right? With each one of these samples, I'm gonna estimate that indirect effect. I'm gonna do that 5,000 times, and then I'm gonna go through and I'm gonna have a sampling distribution of that indirect effect that I've pulled from my own data, okay? And now what I can do is I can go through and I can say, okay, here's my mean, here's my standard deviation. Standard deviation of a sampling distribution is what?
Standard error.
Standard error, right? And so I can go through and say, this is my standard error, right? A more appropriate standard error. Or the other thing I can do is I can say, here's my average, right? So here's my bootstrapped estimate of AB. What I can do is I can go through and say, okay, I'm going to cut off the bottom 025, the part top 025. What did I just create here? The bottom 2.5% of my distribution. Here's the upper 2.5% of my distribution. If I go through and sort of mark lines there, what is and here's my point estimate. What did I just create? Confidence bound. I got a bootstrap confidence bound, right? Where I'm saying my estimate for AB times lower, which is going to be this, and upper, which is going to be this right here. And so again, what I've done, and what you'll see here with the skewed distribution, if I cut off the top 2.5%, the bottom 2.5%, is this confidence bound going to be symmetrical? Nope, the upper end is going to be stretched out here and the lower end is going to be compressed, but it's an empirical estimate for what I can expect based on my estimates of AB. So again, what we're doing here is, because we know the problem with Sobel is that Sobel provides an approximation, but Sobel isn't a normal theory approximation. It's assuming a normal sampling distribution. We know that AB isn't normal, and so Sobel is not precise, right? Which leads to too much type 2 error. So what we can do is we can use bootstrapping procedures to go through and just physically create a sampling distribution of AB based on the data that we have. And then we can go through and calculate standard errors and confidence bounds using that empirical distribution. So again, different types of bootstrap confidence intervals, different procedures we can use. They should all be sort of pretty even, Stephen. Our current version of process uses percentile bootstrap confidence intervals. Just kind of know what that's what's happening, but there are other variations that you can specify in the program. Questions about this? All right, to process, okay? Those of you who use process, right? Pretty easy, straightforward. It's an awesome, slick program. It's sort of brilliant and has opened up all sorts of different things that we had a really hard time doing before, right? And now because process is available to people, there's really no reason to do a Sobel test on anything. Because if you do, you'll probably submit it. Someone beg, hey, use proper methods with this. Okay. The nice thing about process is you'll go through and we'll do this. It's a giant file. You just hit control, you select all and just run it, and that loads the program in. Don't ever tweak or change anything in the original file. It says very clearly in the instructions, don't jack around with this. Don't do it because it won't work right. Just run through that. But then the actual model that you run starts to become very, very easy. Okay. You say process y equals whatever your y variable is. X is whatever your predictor is. M is your mediator. Okay. Total, this is going to just give you an estimate of total effects. Model 4, what process does is it has like a billion different models loaded up into it. A simple mediation model is just model 4. Normal equals 1. This is going to give you your normal theory. It's going to give you your Sabel test for this, right? So you can go to and take a look and compare. Lots of other types of tweaks that you can go through and do with this, but you don't need to worry about that for this class. If you go through and start to use this, you can go through and explore sort of some of the different options and things. Okay. What's really cool, this is the only line of code you need in SPSS to actually run your model. Okay. You're going to download the whole thing, and then it's just this. Okay. All right. So I'm going to open up in your data set. We've got, I'm just going to show you real quick how to run this. So here's our data set that we've been using before to go through and run our stuff. Okay, we have perceived support, utilization, and PTSD here. Okay, I'm going to run the model that we went through and we walked through with our with our Sabel test. I'm going to run this in process. Okay, so what I'm going to do is I'm going to just open up this process macro that I sent you. Okay, watch what I do here. We hit Control All, and I'm just going to run that. Okay. Don't do anything different than that. Just run that. Okay. Now what I'm going to do is, okay, it's to go through, it's ready for use. And there are ways to go through if you use this regularly to go through and kind of load it up into SPSS so you don't have to run this every single time. If you want to do that, sort of go through and play with it. But what I would then do is I would open up a new syntax file. No. Actually run your model, okay? And so all you need to do, if I go through and I pull up and you have your mediation handout, it walks you through just everything that we did sort of in lecture here. But then at the bottom here, we have your process statement. I'm just going to take that statement and paste it into this new file. Okay. And all it is just, it's exactly what we had just had in that slide. It's just what it is. Okay. I'm going to go through, I'm going to have this here, and I'm just going to go through and just run that. It's going to think for a minute. And then what's going to happen? It's just going to dump out your model. Okay. How easy is that? That's beautifully easy. It's very, very, very nice. This is an amazing tool. So long as you know how to use it appropriately and so what to go through and interpret. Okay. People feeling comfortable that they can go through and sort of run process and get this. Okay. Super, super easy. Right. What I want to do then is jump back into our into our output here, just because I want to go through and show you, compare what we did just by hand when we were going through and running through this with our causal steps versus what the process macro is giving you. Okay. And so what it's gonna do is it's gonna tell you what model you ran, what your Y variable is, what your X variable is, what your mediator is, make sure that all looks good. Your sample size, make sure that makes some sense, right? Then you're gonna go through your outcome is support utilization, okay? So it's giving you path A first here, right? So if you go through, you look at your R squared, your statistics here, your coefficients, your constants, things like that. Is there any difference between what process is doing and what you got by just running it by hand? Nope, there sure isn't, okay? Outcome here is support, and then you've got constant PTSD utilized. This is your final model. This is everything going on here, right? Any differences in the coefficients with this? Nope, it's the exact same, okay? Here's your C path, your original C path. Support is your outcome variable. PTSD is your predictor. Anything different across these, okay? Here's what I want you to understand. There is nothing unique that process is doing in estimating sort of these individual paths that you aren't already doing by yourself with just sort of going through and running regressions. There's nothing different in any of these estimates than you already did just by hand. Okay. If we go down through and we take a look, sort of scroll down the output, and you get into this section that says total direct and indirect effects of X on Y. Total effect of X on Y, this is just your C path. Okay. Direct effect of X on Y, this is just your C prime path. And again, 0.030, 0.009, these are the same things that we already got, so just in our regular regression models, right? Here, down here, your normal theory test of effects, this is your Sabel test. This is the exact thing we calculated by hand with Sabel, okay? Look at me in the eyes. The only thing that you get out of process for these simple mediation models, the only thing of use is going to be right here. This indirect effects of X on Y. What you're going to get is your utilization, right? This is just AB. You already know that, right? Because you calculated that. But what you get is a bootstrap standard error and then a lower and an upper confidence bound for that indirect effect, okay? This is the only thing that's unique that process is giving you for this model that you couldn't just get from a very simple series of regression models. This is wicked slick because I don't want to go through and manually resample 5,000 different times with replacement from my own data, aggregate all that, plot it out. Like, so this is beautiful. And this is a massive, massive, massive help for doing something that's consistent with best practices. But know that in your outcome, the only thing that's of use for you in at least for sort of these very simple models is just this bootstrap confidence bound right here. That's it, right? And what we see here is here's my point estimate for my indirect effect. Did I need process to get that? Nope, I could have just calculated that on my own. Well, what process is giving me is a lower bound for this estimate and an upper bound for this estimate. This is what I'm going to go through and look at, okay? Do I need to worry about a p-value? Not interested in a p-value. Could I go through and take this and divide it by that and get like a statistic? Sure, but we don't need to because again, what we're looking at the lower bound, upper bound, do I have evidence for an indirect effect of PTSD on support by way of support utilization based on my output here? Yep, I sure do, right? My best guess for the population estimate is negative 0.021, lower bound negative 0.028, upper bound negative 0.015, right? That's it. That's all I need to report. Questions about this? I'm telling you this because I've gotten papers before where I just went through. Oh, actually, it wasn't for this. It was for a moderation paper. I know how to do moderation. I don't need process to do moderation for me. I went through and presented the thing and I got a reviewer telling me that my results weren't good because I didn't use process. I tell them that for moderation process is going to do the exact same thing. It's a tool. It's not like someone getting mad because you wrote something in R instead of SPSS, right? Here for mediation, process is doing something very, very valuable. But in terms of all the output that you're getting from this, it's good as a double check on your own work, right? If you're seeing differences between what process is giving you and what you did kind of by hand, something went sideways somewhere. But if we go through and we look at the output and process, there's lots and lots of stuff that's going on. The only thing that you need to be concerned about is right down here, your bootstrapped indirect effects right here. Okay, this is the other thing too. As you're going through and doing with this bootstrap process, okay. Laura, you go through and you run a run with process and get your bootstrapped confidence bound for indirect effects. Emma, you run the same thing. Are you going to get the exactly same upper and lower bounds? No, why not?
Because it's gonna like be pulling numbers different.
Exactly. Will your point estimate be the same for your indirect effect? Yeah, it's going to be the same because it has to be, that's basic math, right? But remember that if you were to go through and you were to run this model and you were to run it again, you were to run it again, you were to run it again, each time you're going to get small differences in the upper and lower bound. That's fine. That's a trivial static, right? So just as you're going through and running things, if you don't end up with the exact same upper and lower bounds for your indirect effects, that's good. If you all had the same upper and lower bound for your indirect effects, that would be concerning to me. Okay, so just know that if it's not exactly right on, that's fine. That's a part of the process as opposed to, so like, oh, how do we understand this? Questions? People feeling okay about sort of running process and using this to go through and get the stuff that you need to get out of it? All right. We will finish up with some basic extensions of sort of this moderation mediation process, okay? Thinking about with moderation, right? We talked about and sort of worked with two-way interactions. You can start to build these up and you can have three-way interactions. Could have a four-way interaction. If you're getting four-way interaction, you're getting pretty wild and loose. Like it would be difficult to sort of come up with a good argument for why you would need to think about something that far out, but certainly I guess you could, right? But what we can do is we can start to look at three-way interactions, quadratic, different cubic functions and things along those lines. And there are plenty of reasons to think about a three-way how do I think about a three-way interaction? How would I, let's say I have evidence for a three-way interaction of X, Y, and Z. If that's all you know, can you interpret that? 100%. Right? All we're saying here, so if I have an interaction of X and Y, what does that mean? How do I interpret that? Basic interaction. What is my interaction term tell me?
That's an easy dumb question.
That's something you should have under control. Yeah.
So you're saying is it just the relationship between X and Y?
Yeah.
Yeah, okay. It's too easy. I was like, really dumb. But that's how it
Good. I was hoping that was
Thrown off.
Just when you're saying that the relation between X and Y depends on, or the relation between X and Y outcome depends on sort of the other variable, right? So if I have a three-way interaction of X, Y, and Z, what does that mean?
Depends on both.
Kind of, yeah.
The relation between X and Y and X and Z and Y are.
Yeah. We can start to decode. We can just start peeling variables off, right? I would interpret that and say the interaction of X and Y is dependent on Z, right? The interactive effect of X and Y changes depending on what the level of Z is, right?
But isn't that true in all the directions?
What's that?
But would that be true in like the relation between X and Z that is dependent on Y, or like,
No, what I'm saying is the interaction of X and Y
okay,
depends on if there's an interaction of X, Y, and Z. What I'm saying is the interaction of X and Y looks different at different levels of Z. Okay, so what I would do then to go through and tease that apart is I would maybe take Z, a standard deviation above and below, and then to map out what my interaction effect was, and then look at sort of X at a standard deviation, conditional effect of Y, the standard deviation above X, and standard deviation below X, plot that simple slopes out, and then do the same thing at the different level of Z, right? So again, you can start to sort of pull these apart without, and some people say, oh, you can't interpret a three-way interaction. Sure, for sure can, right? And even if you extended that onto a four-way interaction, you say like, well, the three-way interaction looks different at sort of levels of this, which would, anyway, you start to get a whole lot of different sort of panels that you'd have to go through and sort of describe this, but something that you can go through and do with these models. Same thing with cubics and quadratics and things along those lines. Okay. We can start to look at mediation with covariates. Okay, so here we've got, let's say, let's say I'm looking at the sort of indirect effect here, but I've got some other things that I want to layer in and include as and account for within my model. This is where we get into some of these more complex models. This is where process really starts to shine. You can run these in standard regression models. It just starts to become really hard to go through and disentangle everything. Okay. You can do it, but you have to know the math and sort of be able to tease things apart. We can go through and we start to look at multiple mediators, right? So we talked about one of the limitations of causal steps is that this idea of, you know, well, I've only got, so I'm saying that one thing completely accounts for the relationship between X and Y. That might not be the case. There might be multiple processes. What we can do is start to extend these models out to look at the extent to which X and Y is accounted for by sort of multiple different processes here. Again, something the process starts to become really, really helpful for. You can do this by hand, but it's just a pain, and there's a lot of ways to go through and get sideways with this. Okay, we can also start to look at things like moderated mediation, mediated moderation. If you read Hayes' stuff, this is kind of a classic way of thinking about these two things, but mathematically, these are interchangeable, right? And so this is why sort of where we come up with Hayes's sort of conceptualization of talking about sort of these models as evidence for conditional indirect effects. Okay. So April, going back to sort of the idea that there's a relationship between stress and self-harm that may be different for sort of different subpopulations, right? And what we would say is we have a conditional indirect effect. This indirect effect, the magnitude of this indirect effect changes depending on who we're talking about, right? In some it may be non-existent, in some it may be quite strong. What we would be talking about is a conditional indirect effect here. This indirect effect changes or is dependent on who we're talking about or some other variable, right? And so that's where you get into stuff that's looking sort of like here where we've got some indirect paths and then we've got an interaction sort of going through, and you don't necessarily have to worry about this. You can know that this exists and there are really cool ways to go through and test these. You just want to make sure that you know what you're doing when you're setting these models up. Okay. Think about reporting your regression analyses for papers, publication, or milestones, publications, things like that. Always report means and standard deviations. You're doing everybody a service if you have those descriptors reported. Correlations, these are also really nice to have. So people can go through and see sort of bivariate space, what things are looking like. Okay. Presenting your model R squared. So this is an adequacy of your overall model. We're generally not really concerned about your model R squared in psychological science, but it's just a good piece of information to have out there, right? Reporting your standardized coefficients, unstandardized coefficients. These are nice. Confidence bounds for your unstandardized coefficients. Interval estimates are always good to provide, right? And then finally, I would say reporting squared semi-partial correlations and your F squared statistic. This is gonna give you semi-squared, semi-partial correlation is gonna give you an intuitive effect size. And F squared is gonna give you something that immediately translates into power analyses. That's pretty nice. You can present partial correlations, and partial correlations are really good. The thing that I've found when I'm reporting regression models is your partial correlation is gonna be almost identical to your standardized coefficient. So if you just report a standardized coefficient and then a partial correlation in the same table, it looks like redundant information. So, I mean, I could square it, but then I'm talking about the proportion of residual variability attributable predictor. That's kind of a clunky thing to report, right? I just go through and say, here's F squared. This is benchmark small, medium, large. This is what it is. If someone wants to use that, pull that directly into a power analysis, you're doing them a favor. And then you're not reporting something that ends up pretty redundant with your standardized coefficient. What you never do is square your standardized coefficient and interpret that as a proportion of variability on anything, because that's not how that's calculated. You need to use a partial correlation for that. But just if it's the standardized coefficient, the partial correlation in tables, they always look like the same thing. It's a waste of space. So F squared is nice. And it'll make you look like a boss because you're reporting F squares and things like that. You're like, oh, this person knows. They're probably someone who uses R.
I mean, I'd take that compliment.
Right. All right. That's that. All right. So we ran through this pretty quick. Any questions, concerns about kind of this stuff? Okay. All right. Here's what we're going to do. We decided to go through and have moderation problem set. We have that due Monday, right?
Yeah.
What's that?
Monday, the 24th.
Monday, the 24th. So after spring break. Okay. So we'll have that. Trying to go through and think about when do we want to have mediation set? What I want to do, so we can go through and kick the can on the midterm exam, however far down we want. Problem is sort of we need to still keep having class. We're going to talk about statistic regression and sort of things along those lines, right? And sort of what I'm concerned about is retroactive interference, right? Where we've got new stuff and like the logistic, it's still regression. It's still kind of the same principles and things along those lines. But I don't want to push it so far down that then sort of like the stuff that we're looking at is pretty distal. So I don't know. That mediation set is not. It'll be pretty quick. You'll want to go through. There's the first problem will be calculating confidence bounds around some effect sizes. We didn't cover that in here, but I've got a link to just a screencast demo that walks you through that. You'll create some calculators and stuff. So that's just mostly computation things. And then there's one problem on there that has you working through causal steps and process. And those are just the only two there. So what if tentatively we had mediation set due the 31st?
March.
Yeah, that Monday.
Yeah, so the Monday after PS3 is due. Or
Yeah.
Monza 3 is due.
I'm just trying to think about and then also wanting to give Jenna time to go through and look at it, so to get that turned around. Yeah, and sort of me time to go through it and sort of get this back to you so you can go through and take a look at things. Let's do this. Let's shoot for that as sort of aspirational goal. Okay, because then what we would do is that would put our midterm on April 9th. Okay. And this would give us, so then we'd have class on the 26th and on the 2nd. So we have a couple of classes before we go through. I'm just really hesitant to push that midterm out farther than that. And then test you on stuff that we've been sort of working on way back in the past. This seemed like at least a reasonable sort of target. Okay, cool. Because again, I want to give you opportunities to go through practice, work through some stuff, get feedback before I go through and start testing it in classes on things. Okay, so that's what we'll do. We'll go through and shoot for that. And again, that mediation problem set should not be a hard lift, okay? Particularly after sort of coming off the moderation stuff. Okay, all right. That's a game plan. That's what we work for. And then we'll just kind of take things from there. Okay, awesome. All right, thank you, everybody.